Alright, my friends, welcome. Today we want to look at another very interesting and wonderful topic, circular motion. So I have to pause on that our lesson. I want to pause that our lesson on projectile motion for now and let's look at this one, circular motion. Probably in our next class, in our next video, probably tomorrow, we are going to continue from that topic, projectile motion. But for now, let's quickly visit circular motion. Now, when we talk about circular motion is simply the movement of an object along a circular path about a fixed point. Alright? Now, later, for example, I know you have been wondering what this place is doing, and if you want to eat apple, no, you don't want to eat anything. We want to use it for physics class, alright? So now let's go. Now, let me use it to draw a perfect circle. Okay. Now, the place now, so no eba. If you are taking off eba, no eba, right? So now, this, when an object is moving about a center, this is a center, where an object is moving about it, alright? Now, that of motion is what we call a circular motion. I know that someone will quickly ask me, sir, what about rotational motion? A circular motion is movement of an object about a fixed point, in a circular path. Then what is now rotational motion? My brother, calm down, reduce your temper, yeah? Now, both circular motion and rotational motion, they both involve objects moving in a circular path about the fixed point. Alright? But however, there are major differences between a circular motion and rotational motion. For a circular motion, number one, the direction of an object changes in each revolution, while for the rotational motion, the direction of an object is constant. Number two, for the circular motion, the distance between the object at any point. Now, let's say for example now, this is the object, alright, it's at this point, and the distance from here to here, let's say it is 12 meters. When the object gets to this place, it can be 12.1. When you get to here, it can be what, let's say 12.2. When you get to here, it can be 19.8, and so on and so forth. So you can say that in a circular motion, the distance between the object at any point of the circumference and the center varies. Alright? So that is one thing you need to know. But for a circular motion, it does not vary, it is what? It is constant. So take note of that. That's a very major difference between a circular motion and what? The rotational motion. Now, in a circular motion, what you need to know, there are two types of circular motion. We have the uniform circular motion and non-uniform circular motion. We have the uniform circular motion and non-uniform circular motion. Now, what is uniform circular motion and what is non-uniform circular motion? A motion is said to be uniform when the speed is constant, but is said to be non-uniform when the rate of change of speed is not what? Constant. So anytime you hear a uniform circular motion, it is not uniform in respect to velocity, but rather it is uniform in respect to speed. So when we talk about a uniform circular motion, speed is the one that is constant, not the velocity. Of course, you know before now that velocity depends on speed and direction. And I told you that in circular motion, direction changes, right? So if direction changes, therefore means that velocity will change. So whenever they tell you that a circular motion is uniform, it is in respect to the speed, not the velocity, okay? But however, whether it is a uniform circular motion or a non-uniform circular motion, there are facts that you need to pay attention to. What are those facts? It is very simple. Those facts are basically classified into what we call angular parameters and linear parameters. The first thing we are going to be talking about is what we call amplitude. When we talk about amplitude, amplitude simply means the maximum displacement of an object from an equilibrium position. Now, for example, this is an object at this point, and it keep moving from here to here. Alright, it keep moving from here to here. This is point A. It move from point A to B, then move from point here to point C. I'm going to make it a dotted line because I'm going to clean it later. Alright, then move from here to here, and back to this place, and the circle continue. You agree with me that if you want to represent it in what? In a sign graph, we are going to be having something like this. Isn't it? We are going to be having something like this. Where here to here is this first part. Remember that in a sign graph, each of them is what? 90 degrees. Here to here is 90, here to here is 90, here to here is 90, here to here is 90. That's why they tell you from here to here is a complete circle. So this is the what? The rest position or the equilibrium position. Now, whenever they say something is rest position or equilibrium position, say it simply means where that thing would have been if it was not in motion. Alright, so that's it. So this is where the object would have been if it was not in motion. So that's why it's called the rest or equilibrium position. So from here to here is what we call one circle. What does that mean? Remember I said each of here to here is 90, here to here is 90, here to here is 90, here to here is 90. Meaning that from here to here is what? 90. So this place is what? 90. Here is at 180. Here is what? 270. Here is what? 360. isn't it? So please take note of that. So this maximum displacement, this is the maximum height that can be reached from the what? From the equilibrium position. So they are called what? Amplitude. So amplitude are measured in meters, alright? So that is it for that. Now the next one we are going to be looking at is what we call angular displacement. So let me write the parameters here for you. We have looked at amplitude. We have looked at amplitude. Now I want to look at angular displacement. Angular displacement, alright? Angular displacement. When we talk about angular displacement, it simply refers to the angle turned through during the movement of a body in a circular motion. Now, this was where the object was, and it then moved from here to here. You agree with me that it will cover an angle of, let's say, theta, right? So that is what theta is what we call angular displacement, and it has a formula: theta equals to 2 pi n, where n means number of revolution or number of circle. Are you together? Now, there are two types of displacement. We have the angular displacement and we have the linear displacement. Remember I tell you that circular motion have two parameters: the angular parameters and the linear parameters, right? Now the angular parameters, in the angular parameters, the first one we have is angular displacement, and it has the formula theta equals to 2 pi n. The other type of displacement we can have is the linear displacement. Now the formula to calculate for linear displacement is s equals to 2 pi r over t. 2 pi r over t. There's a formula that shows the relationship between the angular displacement and the linear displacement. What is that formula? The formula is theta equals to s over r. When we cross multiply, we have s is equal to what? Theta over r. Please take note of that. So the first formula you need to know in circular motion is theta equals to 2 pi n or s equals to 2 pi r over s. So the formula that connects the angular displacement and the linear displacement is what? S equals to theta over r. That is the first thing you need to know. Now let's go to the second thing. The second thing we need to know is what we call the frequency. So whether it is a uniform circular motion or a non-uniform circular motion, you need to know what we call frequency. Now what is frequency? Frequency simply means the total number of complete circle in a given time or a specific time. I come again. Frequency simply refers to the total number of complete circle in a given time or a specific time. Now remember I told you that circle simply means total movement. Now when this object moves from this point down to this point, now that is first circle, right? Now from here to this place is what? 2 circles. So since the total number of complete circle it has is 2, so we can say that the frequency of this body in motion is what? Is 2. Alright? So that's it. Now how do you calculate for frequency? You calculate for frequency using F is equals to n over t, where n is the number of circle and t is the time taken, the specific time of the word of the time taken to make the complete circle, and frequency is equal to 1 all over what? Period. So what is period? That will now take us to the next parameters we are going to be looking at. Period is the time taken to make one complete circle. So the time will take the object to move from here down to this point is what we call what? Period. It is represented with capital letter T. Alright? Period is measured in seconds. Frequency is measured in per seconds or s. Take note of that. Frequency is measured in per seconds or s. Alright? Now, what is the formula for period? Period has the formula T equals to what? T or small letter t over n, which is also the same thing as T equals to 1 over what? 1 over f. So what does that mean? It means that the period and frequency, they are inverse of what? Each other. So take note of that. Now, having look at frequency and period, the next thing we are going to be looking at is what we call angular velocity. So the same way we have angular velocity, the same way we also have what? Linear velocity. So angular velocity simply means the rate of change of what? Of angle. The rate of change of angle, alright? And angular velocity is represented with W. Angular velocity is equal to theta over small letter t, theta over t. Remember theta is equal to 2 pi n over t, right? So if we want to go on, remember we can have n over t, which is frequency. So another formula for angular velocity is 2 pi f, which is also defined as 2 pi over t. So these are all the formula for angular velocity. Now the formula that can connect angular velocity and linear velocity is the formula that can connect angular velocity and linear velocity is v equals to wr, where v is the linear velocity, w is the angular velocity, r is the radius. Okay, now let's move on to the angular acceleration. We have angular acceleration and we also have what? Linear acceleration. So angular acceleration is the rate of change of angular velocity, and it's given by something like 5 equal to w over what? W over t. Now there's a formula that connects angular velocity, angular acceleration, and linear acceleration. That formula is A equals to WR. So linear acceleration is equals to angular acceleration times radius of what? Of rotation. So please take note of that, alright? So that is what we are going to take in this first part of the circular motion. Now let's look at some examples and how we can apply all these formulas on the board. Alright, the first question we are going to be looking at is this. It says a stone weld. When we talk about weld, remember those times we used to play on this plane now, you tie rope to a stone to a rope, and then start rotating it, right? That's what we call weld. Alright? A stone weld at the end of a rope 30 centimeters long makes 10 complete revolution in 2 seconds. Find Roman figure 1 angular velocity in radian per second. Roman figure 2 find linear speed. And Roman figure 3 the distance covered in 5 seconds. Okay, this is very simple. Remember that in the anytime you are doing a calculating question, the first step you do is that you should bring out all the parameters. The first parameter we can see here is that they gave us the radius, the length of the rope, which is equal to the radius, 30 centimeters. So convert this centimeter to meter, we are going to be having 0.3 meter. Just divide it by 100 to have 0.3 meter. Okay, now the number of revolution or number of circles is equal to 10, and the time given to us is equal to what? 2 seconds. Okay, and they asked us to calculate for Roman figure 1 the angular velocity. Remember that angular velocity is equal to W. Angular velocity is W equals to theta over t. Alright, and theta is equals to 2 pi n over t. So let's substitute the value of each of these quantities into the equation. We are going to be having 2 times 3.143. Remember, pi is a constant. It has an approximate value of 3.143 times 10 over the time taken 2. So this will cancel this. We are left with 3.143 times 10, which is equals to 31.43 radian per second. Alright, that is that for Roman figure 1. Now Roman figure 2 says that we should calculate the linear speed. Remember, there is a formula that connects the linear speed and the angular velocity, and the formula is W equals to V equal to WR. Okay, so we have gotten our W, which is the angular velocity, and we have our R from the equation. So therefore V is equal to 31.43 times 0.3. That will give us, if we press our calculator, 3 is approximately 9.429 meter per second. Okay, approximately, let's leave it at 9 meter per second. Alright, so that is the answer for number 2. Number 3 says we should calculate for the distance covered in 5 seconds. Distance covered in 5 seconds. Alright, that is. Remember that distance covered will be, since we already have V, remember there's a formula that says V is equal to S over T. Making S of your formula, have S equals to V times what? Times T. So when our V just calculated it to be 9 times time 5 seconds times 5, that will give us what? 45 meter. So that is the answer to the question. It is as simple as that. So let's look at another question and see how we can solve it. The second question says a body covers 1 over 4 circles in a circular motion in 7 seconds. Its angular speed is dash. It's very simple. Remember, the number of circles is equal to 1 over 4, right? And the time taken is t is equal to what? 7 seconds. We are to calculate for angular velocity. What are the formula for angular velocity? Remember, angular velocity is equal to theta over t. Alright? So, and theta is equal to 2 pi n over what? Over t. So we have 2 times 3.143 times 1 over 4 all over 7. Okay? You are very good in mathematics. Okay, let's go. This times this will give us 2 times 3.143 all over 4 all over 7. Okay? Which can also be expressed as 2 times 3.143 all over 4 times what? 7. This times this will give us 6.286 all over 4 times 7 is what? 28. Okay, 6.286 divided by 28. 28 will give us 0.2245 radian per second. Remember, that is the unit for what? Angular velocity. So with this, I believe we have come to an end of this video. So see you in my next video.